Hi, and welcome to this quick recording on how to collect the data for the Density Lab. I have the Density Lab document open right here. You could see at the top that it tells you where to go on the website. Once you're into the Gizmos program, you're going to need your login information. If you don't know what that is, just let me know, send me an email, or let me know in class and I could look it up for you. After you log in, you should see this Density Lab icon here. And so you want to click on Launch to launch the Density Lab. Then if scroll down, what you're going to collect data for is this Part 1, Data Table 1. And you can see here we have a bunch of objects that we're going to calculate the density for. We're going to do this by water displacement, and we want to make sure that we're keeping track of our significant digits. So I'm going to go ahead over into the lab program and do this first one for you. This is object 5. You can see in red here I have it done, so you could use this as an example. So let me go over into the lab program and show you how to get that data. All right, so here's our lab program. You can see there's a whole bunch of objects there. You don't have to do them all. You just have to do the ones that are listed in the data table. Mine is object 5. So to get density, which is grams per volume or mass per volume, I need the mass first. So I'm going to take my object 5 and put it on the scale. And you can see the scale reads 3.9 grams, and whatever balance you're using, whether it's this one here or if you're in a chemistry lab and you're using the balance, you should write down all of the digits that the balance gives you. They're all significant. So you go back over into the data table and write 3.9 grams. Next, I'm going to go ahead and take my object and put it into the graduated cylinder. You can see here that they're already reading the graduated cylinder for us and telling us it's starting at 400 milliliters, which is why on the lab document, you'll see if you scroll down, I have some practice problems that ask you to read volume off of a graduated cylinder, because unfortunately here they're doing it for us. But anyway, the starting volume is 400 milliliters. You want to put that into your data table, 400.0 milliliters. And now I'm going to take my object and drop it into the graduated cylinder. And you can see the volume of the water went up to 403.5 milliliters. That's your final volume. And so to get the volume of your object, you would subtract those two volumes. Right? And so my ultimate volume of this object then would be 3.5 milliliters after I subtract those two. Finally, over here we have a container of water or a beaker of water. The density of water is 1. And so once you go over into your lab document and calculate the density, you'll be able to determine whether the object's going to sink or float in water. Even before you calculate the density, you can make a prediction about whether you feel this object is going to sink or float, and then give it a try. So I'm going to take my object and put it back over here into the water, and you can see it sinking. And so what that tells me is that when I calculate my density, it definitely has to be larger than 1, right? So if this is sinking to the bottom of the water, then the density of the object is greater than the density of the water. And so again, it's probably pretty obvious once you do your calculations whether it's going to be greater than or less than 1. But I just want you to take a moment to make a prediction, to compare, to just think about density and think about whether objects are going to sink or float. Anyway, I'm going to go ahead and grab my object and put it back on the shelf. Again, and so to review, we're going to take the mass, we're going to take the initial volume, the final volume, subtract, and then we are going to predict or try out and see if that object is going to sink or float in water. That's going to tell us whether the density of the object is bigger or smaller than the density of water. All right, so let me go back to the lab document real quick. And you can see I plugged in all this information. So the mass, I had 3.9 grams, my initial volume, my final volume. And so now I subtract these two numbers to get the volume of my object. The density is 3.9 divided by 3.5, right? Mass per volume. And so I get 1.1 grams per milliliter. I have 2 significant digits because my mass has 2 significant digits. I'm not sure if you're going to get a little bit more depending on which object you do. So you want to make sure you're paying attention to the number of significant digits in your final answer. My volumes had 4 significant digits and my mass only had 2. Technically, what I probably should, well, I'll leave it the way it is. Technically, what you probably should do, what I should probably do here is add 2 zeros. Because my initial volume had 4 significant digits, my final volume had 4 significant digits, so my calculated volume should also have 4 significant digits when I'm subtracting. But anyway, ultimately the answer is the same because I'm starting off with 2 significant digits in my mass and I have 4 in my volume, and so my answer can't have more than the number with the least amount. So since 2 is the least amount, I need to make sure that my answer only has 2 significant digits. So 1.1 grams per milliliter. And then finally, we saw that the object sunk in the water. So will the object float? No. I know that because I tried it out. But also you could take a look at the densities. I put the density of water here for us, which is 1 gram per milliliter. And obviously our density we've calculated is greater than 1 gram per milliliter. So it should sink, and it did. So now what you have to do is go back into the lab program and do the rest of the objects listed here. So 1, 4, 8, 10, and object B. You could do more if you like, but I just chose 5 for us to get into our data table. Once you're done filling in the data table and doing your calculations there, you're done with the gizmos, and you could scroll down to part 2 and keep going through the rest of the document. I have separate recordings for the other parts of the lab. If you need any help, just let me know, and good luck with your collecting your data.